So, what if the secret to building an AI that never forgets is actually hidden inside one of the oldest mysteries in all of mathematics? We're about to dive into a pretty wild idea today, one that connects a cutting edge AI architecture with the strange, beautiful patterns of prime numbers.
This is really the million-dollar question in AI. We're building these incredible, powerful models, but they all have this one fundamental flaw. They forget. And I don't mean they forget a little bit, we're talking catastrophic failure. And to really get why this new idea is so cool, we first have to understand just how big of a problem this is. For an AI, forgetting isn't just a minor bug. It's a huge wall blocking the path to true, continuous intelligence.
Okay, so imagine you spend months teaching an AI to identify every bird species out there. It gets amazing at it. Then you decide to teach it about fish. Well, the problem is, in the process of learning about fish, the AI might just completely overwrite everything it knew about birds. It's not just a little rusty on robins. It's as if it never knew what a bird was in the first place. That's catastrophic forgetting, and it's what stops AI from learning new things one after another, like we do.
So how in the world do you fix a problem that big? Well, you don't just tweak the code. You have to go back to the drawing board and engineer a completely new kind of brain from the ground up, one that's designed from day one to learn, grow, and actually remember.
And here it is. Yeah, it's a mouthful, I know. The Governed Self-Adaptive Evolutionary Hierarchical Recursive Variational Autoencoder, or GSAE-HRVA for, well, it's not much shorter. But look, just forget the name. All you need to know is that this thing is built to think deeply and learn constantly, without ever hitting that memory wall.
So this thing's power really comes from a few key breakthroughs. It's got what's called deep reasoning, which means it can think about big, abstract ideas slowly while also handling tiny details really fast, kind of like our own brains. It uses evolutionary tuning to constantly try things out and improve itself. It even has a built-in hallucination check, always asking itself, wait, is this actually valid? Which slashes errors by a solid 15%. And the best part? It directly attacks catastrophic forgetting by using tricks like generative replay, basically rehearsing old memories while it learns new skills.
But it's not just about being powerful, it's also about being safe. This AI is built with a 5-level governance structure to keep it in check. It starts at the bottom with just processing data, then moves up through layers that keep it stable and help it improve, all the way to the top identity layer. Now, this level is the boss. It checks all its own work, and this is the crucial part, it needs a human to sign off on any major changes to its core programming. It's like a powerful brain with a built-in conscience.
Okay, so we have this incredibly advanced AI brain. Got it. Now, I want you to put all that aside for a second, because we're going to switch gears completely. We're leaving the world of engineering and diving into the beautiful, strange, abstract world of pure mathematics, specifically prime numbers. For centuries, we've thought of prime numbers as, well, basically random. They're the atoms of mathematics, the building blocks for all other numbers, but they just seem to pop up without any clear pattern. But what if all that randomness is just an illusion? What if it's hiding something much, much deeper? This is the first leap in a theory called the prime scalar field. It says, stop looking at the primes themselves, 2, 3, 5, 7, 11. Instead, look at the gaps between them. So the space between 7 and 11 is 4. The space between 11 and 13 is 2. The theory suggests we treat these gaps, these numbers, as if they were frequencies in some kind of signal. And once you do that, something absolutely incredible happens. When you analyze that signal of gaps, clear, distinct harmonic waves just appear out of the noise. It's like tuning a radio and finding a crystal clear station where there was only static before. The randomness melts away, and you're left with what looks like musical notes. It's as if the primes aren't random at all. They're singing. And it gets even wilder. These waves don't just exist on their own. They interact and resonate with each other, creating these complex, beautiful, multidimensional patterns. The theory suggests this forms a perfect, infinite grid, like a crystal made of pure information, where every single point has its own unique resonant frequency.
And this, right here, is where our two stories collide. On one hand, we have an AI engineered to remember. On the other, we have a fundamental pattern of the universe that looks like a perfect system for storing information. So what happens when you put them together? This is where things get really fascinating and, admittedly, a little speculative. We're asking if this music of the primes could be the key to unlocking an even more powerful, more stable form of artificial intelligence.
It all comes down to how an AI organizes what it knows internally in something called its latent space. In a typical AI, this space is messy. Things get jumbled up, they interfere with each other, and that's what causes forgetting. But a latent space built on prime harmonics would be the exact opposite. It would be inherently structured. Every memory could be stored as its own unique wave, vibrating in its own space without ever overlapping. You'd get perfect, lossless recall. The potential here is just massive. For its internal map of the world, it would be far more stable and efficient. For its self-improvement, the AI wouldn't just be guessing, it would be guided by these natural harmonies toward better answers. And for forgetting, well, it could use these prime patterns to lock in old memories, making them almost impossible to interfere with.
Okay, this all sounds amazing, but you have to be thinking, is it practical? I mean, this GSA-HRVA is already a beast. It doubles the training time of a normal AI. Adding another complex layer of prime number theory on top of that must be incredibly expensive, right? Well, you might be surprised.
Get this, integrating the entire prime scalar field adds, on average, only about 10% more training time. That's it. For all that structure and stability, the computational cost is marginal. This isn't some sci-fi dream for 100 years from now. This is a totally viable path for research, like right now. And that just leaves us with this one final, kind of mind-bending thought. We spend so much time looking at biology, trying to copy the human brain to build better AI, but maybe we should also be looking at the fundamental structures of mathematics itself. Maybe the most elegant, the most robust form of intelligence isn't one that mimics life, but one that resonates with the very fabric of logic, with the music of the primes.